Hey, welcome back, everybody. So right now we have a very interesting session for you. We're going to be covering all of FreeFlyer's capabilities by the FreeFlyer project manager, Cody Thompson. As I mentioned, Cody perhaps knows FreeFlyer better than anybody else, so feel free to ask him as many questions as you can. And with that being said, Cody, thank you for taking the time, and please go ahead.
All right, thank you very much, Motaz, really appreciate that. So I am Cody Thompson. I am the project manager for FreeFlyer, which means that I manage, the release, the schedule, the logistics of the operation, more or less. So I have a keen awareness of a lot of the things going on, and hopefully I can pass a lot of that on to you now. So what I'm going to be covering, as Motaz mentioned, is the capabilities overview of FreeFlyer. So more or less, this comes down to all of the things that FreeFlyer can achieve, what you can do with it. We will touch a little bit on what it is at a high level. I know you've heard a little bit about this from Michael Barton already, assuming you're not just tuning in. And so based on that, we're just going to cover a little bit of it. I'm not going to go into too much depth. You're going to see a lot more of this over the course of the week, of course. We'll then be touching on all the difference between features and capabilities, what they are, and what you can do. We'll talk then about the features and the capabilities. So obviously first I'm going to tell you what they are, and then we're going to go over them. Sounds good. And then we'll finish up with a bunch of learning resources. So this is going to be really helpful if, for instance, you're just starting out with FreeFlyer now and you're like, man, wow, all those things sound so interesting. How do I get that going? And so that'll hopefully get you going on that. So without further ado, I will jump right in. So let's talk what FreeFlyer is. So you've heard it all before. FreeFlyer is a commercial off-the-shelf, it's a flight dynamics tool. It's used worldwide to solve aerospace-related problems in our industry. And I'm not going to go into too much of the detail on the flight heritage because there was a whole presentation on that from Michael just a moment ago, but it's been used in over 200 missions. It's very flight-proven, it's ready, it's TRL-9, it's all sorts of just got great credentials there. And some specific groups that I think I wanted to call out here. It's in use by NASA, NOAA, the Air Force, the Space Force, the intelligence community, as well as commercial and international satellite providers as well. So it's all over the place. It's got a big background, it's very commonly used. So the way we're going to introduce FreeFlyer here is we're going to talk about the 3 stages of mission development that you normally use FreeFlyer in, how it gets used in those areas, and so on and so forth. That's a good way of kind of approaching this, because otherwise it can be overbearing. To think, oh my gosh, it can be used for so many different things. Obviously, if you're using FreeFlyer or considering using FreeFlyer for something outside the normal operational mission workflow, it's still perfectly valid for that, of course. So don't worry about that. So let's just jump right into that. Those 3 special groups of topics that we're going to be covering here, design. So this is the first stage of your mission. This is when I'm interested in where does this start? How do I make sure I'm making the right choices? How do I develop requirements for my mission? How do I sort of figure out all the different options there? So you can, example being, you could define a number of satellite orbits, any regime you want, GEO, LEO, MEO, you name it. You can define constellation parameters, decide how many spacecraft you have in your constellation. You can target maneuvers to plan some initial things, and then you can simulate the full mission life cycle. This is all before your mission has even really began, right? So you maybe just got funding and you're interested in figuring things out. FreeFlyer is great for that initial design phase. Now let's say after you've done some of that initial design, you want to get into the nitty-gritty of the analysis. You have some mission requirements, you have a customer, maybe you're doing some communication satellite work or something like that. You need to perform analysis against all those requirements and make sure that your plan is going to work. And maybe go back to the design phase if something about your plan won't work. FreeFlyer is used frequently for that. So this would be like parametric trade studies is a good example of something like that. Let me canvas all the opportunities here, see what makes sense, pick out the few that are of interest to me, and then maybe perform additional analysis on those particular examples that are really interesting. This could be, coverage analysis from spacecraft, ground sensor. You have ground vehicles, you have drones, aircraft, you name it. You want to try to figure out, what makes sense? Do we have coverage here? What's going to maximize my coverage? What kind of minimize fuel consumption here? So maybe I'm putting out some reports in that respect, and a whole bunch more. We'll obviously talk about all of the different sorts of features you might use in this analysis stage in a little bit, but for now, just accept that there's a lot you can do here, and it's very commonly used for that. This is additionally augmented by FreeFlyer's ability to play nicely with all other sorts of software. The example used here is you can integrate directly with the MATLAB API so that, hey, maybe I'm a MATLAB user and I want to make FreeFlyer talk to MATLAB very natively. I want to make it simple and fast. I want to avoid cases where it's a slow socket connection or something. Maybe I want to do something more sophisticated. And you certainly have that option with FreeFlyer. And then so now you've done all of the design, all of the analysis, you are now live. You have launched your mission. Your mission is in operational state. It's on life. So there's a lot going on, and you need to make sure your operators know how to use everything and know how to manage your spacecraft. This is a very common use case for FreeFlyer as well, in the operation state where you have mission plans, which are essentially just objects where you tell FreeFlyer, this is what I want you to do, and then you save it, and then you can run that repeatedly. So these mission plans can then be tailored for a specific operational style, where maybe I load up a mission plan for maneuver planning because, oh no, there's a conjunction data message that came in from the Space Force, and we suddenly have to avoid this collision, and we have to plan around that on the spot, on the operational floor. So I'm running FreeFlyer to figure out, okay, what is the probability of collision? What are the issues here? What maneuver can I perform to avoid that collision? Or anything. That's just one example of many. And this goes hand in hand with sort of all the other integration things that I mentioned just briefly a little bit ago with the analysis, in that I can have FreeFlyer talk to every other part of my ground system. Very rarely, and quite frankly, it shouldn't happen, is FreeFlyer going to be your entire ground system. There's so many other components, right? I need to transfer telemetry from sensor readings into FreeFlyer. Maybe I need to transfer that all over the place. Maybe I have other tools for line of sight calculators, or maybe you have your own conjunction and assessment tool that maybe is built with FreeFlyer, or maybe you built it on the side, or maybe something else. You need all of these to talk to each other. So these third-party tools, there's some of this legacy code. Maybe you have Fortran stuff that you've configured to run and you don't want to mess with it because, heaven forbid, it breaks and you have to figure out how to edit that Fortran code or something. And you just need FreeFlyer to play nicely with it. And FreeFlyer can. There's a very nice integration step that you can do there. And we'll cover the exact mechanism of that in a little bit, but suffice it to say that FreeFlyer plays nicely with them. And that's really important for these operational systems. So that covers essentially how FreeFlyer gets used. I'm not going to open up FreeFlyer and walk you around in it in this presentation. You're going to be seeing a lot of that later this week. So please tune in for all those presentations on that. I will provide some resources to help you get along in that respect if you're looking for that, though. So before we get into what are the features and what are the capabilities of FreeFlyer, let's talk about what the two are and why do we distinguish between them. So I distinguish between them because they represent different things. And it's a good distinguishing feature because you can understand what it's trying to achieve when we talk about a feature versus a capability. And you'll see this all throughout the rest of the slide deck as well, in that features essentially represent what can the software do to enable you to more easily access the Astrodynamics? What things can FreeFlyer do for you, or does FreeFlyer simplify for you so that you can get at what you really care about, which is my spacecraft is moving or my system is changing and I need to understand that. So we'll talk about these first in this presentation. So you'll expect to see those in the next couple slides. They'll all be labeled, no worries. And so that's the first part. How do I access all the Astrodynamics? The capabilities then, without any surprise whatsoever, are the Astrodynamic functionalities themselves. So what capabilities does FreeFlyer have to actually perform the analysis I'm interested in? So features enabling access to capabilities, they play nicely with one another. They're both very important and we care about them equally, right? Because it doesn't matter how good your Astrodynamics engine is if you can't access any of the things in it. Meanwhile, what purpose does an integrated development environment have if there's no value in whatever you're building with it? So they're very much mutually inclusive. They require one another. So hopefully that makes sense. Obviously, if you have any questions at any point throughout this presentation, you know the drill. You can ask them, moderators will ask them at the end of me, I will answer them, and so on. So let's dive in. Let's actually see what some of these features and capabilities are. So we'll start with the first one. This one's pretty straightforward, right? I do Astrodynamics. I want to see what happens. I want to see the output. And this can be visual, which is awesome. So you love seeing a 3D planetary view. It looks really cool. You can see, oh, look at the planet. I can rotate around. I can see my orbit in three-dimensional space. maybe I'm looking at a 2D map, which you can actually see on this slide directly. That might be useful because, gee, I'm looking for where my spacecraft is going to be traveling over on the Earth. And that's kind of hard to line up in a 3D view, right? So it's easier to see that in 2D. You obviously also get the Terminator lines and everything else. But there's a lot more too. You can generate Cartesian and polar plots in 2 dimensions. You can report data to the screen. This is pretty straightforward. Hey, I want a number output. There's a lot of ways that you can visualize that number output. Maybe you just want to report value, and great, you get the number. Or maybe I want to see that number changing over time. Maybe I'm interested in, hey, this number is changing, so I want it to constantly update. And then if it gets into a certain range, maybe it's like a warning or an error threshold, change the color of that number to let me know I'm in danger or whatever. That's useful. Or maybe you want to do something really sophisticated and you want to just build out a complete spreadsheet. You can totally do that in FreeFlyer. You just build out a spreadsheet on the screen that maybe flashes a bunch of cells in a bunch of different colors based on a bunch of different thresholds. Maybe it reports out some numbers, maybe it reports out some actual data lines and diagnostics, who knows? The world is your oyster at that point. You can kind of do whatever you want. Obviously, that's the hardest one to set up because you can do anything. And the other ones are simplifications of that just make your life easier when you're trying to put it together. And then so you obviously those spreadsheets of reporting data. You also can use console data as well. And we distinguish the consoles because they're usually used in operational settings as a diagnostics tool. If you imagine, hey, I have some operational element that I need to work with, very regularly you have some kind of column over on the left, the right, the top, wherever it is, and you want this thing to be spitting out, I have succeeded at this task, I have succeeded at this task, we've started this task, there was an error in this task, and it tells you some information of that. That'll help you debug that if something goes wrong in operations. Or more likely, while you're developing it, it can help you kind of figure out, this is a situation that we need to handle. So you can kind of work around any things that you're causing errors with so that FreeFlyer can continue and recover. So that's a good approach to doing that, reporting that data out to the console. And then of course, the last one I mentioned on this list is you want to put your output to a file because FreeFlyer is inevitably not the only tool that you're using. And based on that, I want to be able to see my data in whatever tool I prefer for that particular data type. And you need to be able to get that data out, obviously. So you can report it out in all sorts of formats, whatever you want. So generating output, pretty key. Now, the next part of this is the FreeFlyer scripting language. Now, this is a really important part of the FreeFlyer paradigm because it's probably, the way I would describe it is the #1 separator between FreeFlyer and other tools in that FreeFlyer is a scripting language first tool. The good analog here, if you're an engineer and familiar with this concept, is MATLAB. Right? Obviously, MATLAB is great. You use it for all sorts of mathematical analyses, physics analyses, anything you can imagine in a lot of ways. And the nice thing about it is it's scripting language first. I can tell it to do some stuff, great. There are some GUIs, some options to click through, whatever, sure, they have options for that. But I can program an M file that tells MATLAB to just do this set of computations and spit out the answer in whatever form I want. And I can make them play nicely with one another, run out a whole suite of things, and go from there. FreeFlyer is very similar in that respect. It's scripting first. You have GUIs, you have options, you have an interface to integrate with and work with, and that's great if that's what you prefer. But the real power comes from being able to do virtually anything you want in the scripting language. Basically, this lets you bypass, say, man, if I really wanted a fast Fourier transform in FreeFlyer, you might really want that for some reason. We don't have a native fast Fourier transform capability in FreeFlyer just because people haven't really asked for it. But if you're a user who wants it, well, gee, wouldn't it be great if you had that? Yeah, it would. You want to be able to use it instead of having to call into another tool to do it for you. You can just script the algorithm for FFT into FreeFlyer if you want it. Set it into a procedure, set it up so that it runs in an external area, great, and then you can just call into it whenever you want to. It's kind of a classic example. If I were actually trying to do an FFT, I'd probably do some of the other things that we'll talk about on the next slide, but regardless, they have the option to do that. It's worth noting that anything that you can touch in the GUI, so if you have a double click option on an object dialog, a command dialog, whatever, all of these options are available in the script. The script has everything. Now the reverse is not true, right? So some of the objects that are in FreeFlyer, because it's scripting first, it lets us get really nitty gritty. Let's just get into the weeds and get the details of what makes the thing really effective. And to do that, we have some very advanced capabilities that are only present in script because there's so many knobs that you have to turn to set them up. And trying to imagine that in a GUI that anyone ever clicked through would be a nightmare. As a user, you don't even want to experience that. That's terrible. So the script obviously improves that user experience substantially. Now I have a good screenshot on this slide of what the scripting language looks like, some very basic stuff. I declared a spacecraft, I gave it a name. I am hovering over one property on this spacecraft, and you can see the little IntelliSense pop up, which is what we call it, that gives you some information. So we'll talk more about the integrated development environment on the next slide, but let's just put it in perspective. If you've ever used an integrated development environment, classically referred to as an IDE before, you'll recognize a lot of the features in FreeFlyer as standards. So features of the IDE. The classic example I like giving here is Visual Studio, right? If you are a hardcore developer or have ever done any hardcore development, okay, there are other options, of course, but you've probably seen Visual Studio or at least heard of it. It's very effective. It has a lot of very great tools for diagnosing issues, giving you suggestions, simplifying programming so that you're not trying to do so much guesswork. A lot of that is in FreeFlyer as well. So you'll see these standard features in there. I'll list out a few of these. These are really relevant. You saw it on the earlier slide, the object-oriented design. I declare spacecraft. I have access to members of that spacecraft. Awesome. The GUI that I mentioned that exists, that everyone can use if you want, it helps you teach the syntax of the scripting language to yourself. So you maybe click open a spacecraft and I'm like, oh yeah, I'm interested in the Cartesian elements of my spacecraft in its orbital state. Great. I can hover over those little properties and it'll tell me all about them so I can then, in the future, go into the script and program them in. You have the full access to a debugger to diagnose any scripting issues you run into. Really useful. So you have a problem, geez, I don't understand what's going on, and you can kind of work through that without much issue. Pretty straightforward. You have full flow control syntax. So this is going to be your loops. This is your if conditional statements. These are try blocks, your switch cases, anything that'll help you kind of organize your code in a way that simplifies it, makes it more readable and more familiar to you, right? Because maybe you're coming from a programming background, even if you're not, you want to be able to read everything just fine. You have very nice convenience functions available for all sorts of conversions, attitude, time system management, string manipulation, mathematical constants, the works, right? All the things you'd expect that make your life easier. You don't have to program in Pi. Pi is available. Amazing. Obviously, I mentioned before, procedures, developing your own function calls. These can be external, like I said, so I can put them on a network drive, put them in a repository, and then they can be version controlled along with the rest of my system. I can then pull it down on another computer. I can commit it. I can share it across my entire team. Very effective for ground system control, design, and development there. And I showed you an example of it, but you have that autocomplete functionality where as you start typing things, it pops up suggestions intelligently based on what you're typing, because you don't want to type every letter of everything you're typing. Save yourself some time, really. And then, of course, like all other things, save yourself some time. Macros can save you on a bunch of repeat code. Obviously, sometimes it makes sense to abstract things into a procedure. Sometimes it doesn't, and you just have to write the same thing a bunch of times, in which case a macro can help out a lot there. So lots of options, lots of power in our scripting language. It's a big core feature of the tool. And then the next feature, this kind of plays into some of the things I've already talked about. So none of this should be a surprise, but obviously interfacing with external resources is really important, right? I need FreeFlyer to talk to whatever else is in my ground system, anything else I'm happen to be using. So it can do all sorts of stuff. You have socket, input, output, you have database, any driver you can imagine, relational or otherwise. You have MATLAB integration. We call it out specifically because it's important and a lot of users think it's really important for them. So we made a special thing for it, just to give it extra care to make sure it worked really well. File management, this can be ASCII binary, pretty much anything you want. You can write out any file in any format. It's pretty straightforward. You can do email, custom GUIs, arbitrary program execution. That essentially means I can tell FreeFlyer to run anything on my computer. One thing you'll note is that FreeFlyer has a number of capabilities and features. Email is a good example of this. Oftentimes nowadays, when developing a ground system, I wouldn't recommend actually using FreeFlyer's email functionality. And you might go, wow, why is the person who manages the project of FreeFlyer telling me not to use this feature? And the answer is because the way you can integrate FreeFlyer into a sophisticated ground system, usually you can use the sophisticated components available to you in C# or C++ or whatever programming language you're using to kind of abstract that stuff away and do it in a really fast and efficient way, because you're not using FreeFlyer, which is the high-level language, to do stuff that can be achieved by something lower level. This is the case of if you ever start using FreeFlyer for some big mission or whatever, ask us. We have a lot of experience building these missions. AI Solutions is not just kind of a software company. We're also a services company. And a lot of that services comes from how do you use FreeFlyer in an intelligent way? And we want to save everyone time, right? So the idea is you do the things that make sense. We'll make the suggestions that make sense for you. Our tech support team's great for this. The next thing I'll call attention to is there's two things that are really cool that go kind of above and beyond just like the available interface list. There's extensions. An extension is essentially your ability to create a custom object in FreeFlyer. This object can do virtually whatever you can imagine. A very typical use case for this is I have an external DLL for something. I'll use my previous example, the fast Fourier transform, right? Normally, you don't want to program in your own algorithm for FFTs. It's pretty complicated. You maybe don't know it very well. Someone else has probably done it already. Save yourself some time. So maybe there's an external library, some kind of number binary DLL or whatever, some scientific library or whatever. You could just create an extension that serves as a bridge from FreeFlyer to this external DLL, make them talk, and then create an object called fast Fourier transform in FreeFlyer that you just set in some properties. Great job. You tell it to run. Good. You run out. You get your FFT. It becomes a lot simpler because you're not managing this algorithm. You're not doing the research. You just integrate with something that already has it. Very nice. Extensions are also really good for adding custom forces. This was mentioned by Barton recently in the previous demonstration. The example being, I have some custom force that I need to get into the integrator level. How do I do that? Well, I can build any custom force I can imagine, and I can kind of just plug it in there. Very convenient for building out some like specific nuanced drag models that maybe aren't very widely used, but are really relevant for your mission, as an example. The next thing, and the thing that deserves its own slide, is the Runtime API. So this is what I was talking about when I said that there are intelligent ways to bake FreeFlyer into your ground system, and from there kind of do what makes sense. This would be the example of email, right? There are a lot of email libraries. There are a lot of socket libraries as well for your programming languages, your C, your C++, your C#, Java, Python, whatever, any of the supported languages that we use. And from there, you can kind of build out something that makes sense. You can abstract things away from FreeFlyer. You can make FreeFlyer focus on just the Astrodynamics if that's what makes sense. Obviously, these features exist in FreeFlyer. If you want to use them, of course, please do so if it makes sense for you. But in most cases, people abstract those away nowadays. They're looking for more sophisticated systems that are kind of well-balanced and are using things only for the specific purpose for which they exist, which is nice. That's very convenient. The biggest thing is that this makes FreeFlyer a client software, right? You have your big driver solution. This is my driver application that runs my whole ground system. It talks to everything. It does everything. It kicks off tasks and mission plans in FreeFlyer and whatever. And it integrates FreeFlyer directly into these ground systems. Really nice. You can, of course, control program flow really nicely when you're doing something like this. You have a sequential. I can make things run one after another, parallel. I can spread them out across threads. I can use some of the asynchronous capabilities baked into FreeFlyer's API. You can divide functionality where it makes sense. This really goes back to what I was saying in the email example. So yeah, the Runtime API, pretty important, pretty big feature, very commonly used to enable a lot of ground systems these days. And that should be the last feature that we'll cover. So now let's dig into some of the Astrodynamics. So if you kind of assume, hey, I have all these features that enable access to this stuff, now what can FreeFlyer actually do? Well, let's get into it. So we talk about this one first, spacecraft propagation, because it's kind of the focus of everything, right? It's all flight dynamics in some form is revolving around the usage of an interactions with either a single or multiple satellites. Now, a satellite in this context could be a vehicle. It could be a ground vehicle. Obviously, it could be a drone, it could be an aircraft, could be something of interest. And then that thing, that vehicle object is ultimately what matters here. So this feature, this capability focuses around how to interact with that. And it's used for all facets of flight dynamics, right? Obviously, the most important one, you can propagate your orbit. Here's a 3D planetary view on this slide. You can actually see a propagation of orbit happening. You've seen this in videos throughout this. I don't need to belabor this point too much. It's a very important capability. It's probably the most important one, quite frankly. And it's used for literally everything we're about to cover, right? All these other things that are going over, in this slide deck, you're going to be seeing all sorts of them using spacecraft propagation at their core. Obviously, you have access to all sorts of kind of subsystems as well. These are going to be your sensors. I want my spacecraft to point and look at something, my antennas, propulsion systems, hardware. So this could be like tanks, thrusters, valves, things like that. We'll cover a little bit more on those later, but yeah. And it's obviously highly configurable. Because it's so important and you can do kind of whatever you want with it, it's important that you can set it up in the way that is correct. This could be using any manner of integrator. You have the ability to actually perform integration. So this would be like your Runge-Kutta methods or any of the other options that we have. Also, you can use ephemerides, right? Maybe I know exactly the path that my spacecraft's taking. Maybe it's taking it in the past and I'm doing some post-mortem analysis or something like that. Or maybe I just have predicted events. Maybe my mission hasn't started yet. And in order to do any of this stuff, I have all this stuff in predicted. Obviously, all those are very commonly used, and you want to be able to import them and use them appropriately. You can configure your initial state however you want, whatever coordinate system makes sense, NORAD, Cartesian, Keplerian, you name it. You have access to physical properties, my coefficients of drag and so on and so forth. How much mass does my spacecraft have? And then what forces apply to it? This is obviously really important. Do I care about all of the gravity in the universe? Or am I outside the spheres of influence of most of things? Am I looking for interplanetary analyses? Maybe I need to turn those on. Maybe I'm interested in a whole bunch of atmospheric stuff. Maybe I have SRP on. Maybe that matters. Or maybe I have something custom entirely. Like I was talking about with extensions, maybe you've built something out there you want to import and you need to be able to integrate that. So spacecraft propagation is a big deal. Now, obviously you're going to be hearing about this all throughout the presentations this week. So tune in any other day, any other presentation, you're going to see something about spacecraft propagation. No worries. But we do have something specifically on Friday that I want to call attention to for constellation analysis, where Michael Volley will specifically be covering the Starlink analysis of a particular constellation, and he'll be going over a lot of very interesting topics there. If you're looking for something advanced that's going to be showing you really in-depth what FreeFlyer is capable of, check that one out. I think you'll like it a lot. You'll see these kinds of callouts throughout, right? I'm trying to make sure that you know what's available this week so that you can make good decisions with your time, more or less. Anyway, let's move on. The next big capability is going to be one of the more common ones that is used, coverage and contact analysis. This is using the sensors that I briefly talked about before and ultimately kind of saying, okay, well, point these things at something and tell me information. Do I have line of sight visibility? Can I perform some kind of chain analysis? The common example here is I am at a ground system somewhere on Earth. Awesome. My spacecraft is somewhere on the other side of the planet. Well, obviously I can't see through Earth, so there's a problem there. But maybe there's a TDRS satellite up there or something, and I can see that, and it can see my spacecraft, and I can use that as a relay. That kind of chain visibility is really important too, right? So you can perform that analysis. And you can, of course, factor in atmospheric refraction there if you mind, if you want to. Most people, whatever. Do what makes sense for you, of course. You can set these sensor cones up on any vehicle. So that could be spacecraft, that could be ground vehicle, you name it. You can determine contact with areas as well. It's not just about like, is my ground system in the sensor cone? It could be like, am I inside of a shape in space? And the obvious question here is, well, a shape in space, that doesn't make any sense. Except, what if you're in GEO, right? And you have a keep-in box, and you want to make sure that your spacecraft is always looking at the right place, because it'll drift, right? No orbit is perfect in that respect. And so you may have to do some orbit correction maneuvers in order to keep yourself inside the actual box of your interest. And that's very regularly done in sort of like a shape analysis, right? I have some keep-in box. Maybe I have some kind of coverage analysis grid on a celestial object. This could be on Earth, obviously, is a good example. I have something in low Earth orbit that's doing a lot of passes over the Earth and kind of changing its orbit very regularly. I'm interested in how many times does it see a particular area. And you can look at that kind of revisit analysis very easily with this. It's called a point group in FreeFlyer if you're interested in looking it up later. So there's some pretty cool examples in our sample mission plan directory that'll show you more. The other big example here is a proximity detection ellipsoid centered on your spacecraft. And this is very commonly used for conjunction assessment. One of the capabilities we'll talk about later, I won't steal too much thunder from myself there, but the important thing here is I can kind of model the hard body radius of my spacecraft. And when two of them come together, I can detect that collision of that hard body radius and basically just go, hey, we need to do some further analysis. What's my actual probability collision? What makes sense? What can I do? Things like that. And it's worth noting that there's this concept in FreeFlyer called an interval method, which essentially enables you to find exact start and end times for your events. And that's relevant because if you're just propagating your spacecraft along using an integrator at a fixed step size, you might skip over the exact moment when you entered into some event. Maybe I'm looking for when exactly I entered into shadow. That's a good example of that. And based on that, you want to find that exact time. The interval method is going to help you find that. It's going to basically perform kind of like a binary analysis of that and kind of binary composite to figure out what makes sense and where that actual split is, where your actual event is, more or less how that works. And obviously I have a picture here of what a sensor looks like in case you're interested. All right, cool. So carbon and contact analysis, big deal, very important. Let's move on. Let's talk a little bit more about what comes next, the maneuvering and targeting. We've obviously briefly mentioned this in a past slide a couple times, when I mentioned like fuel consumption reports and things like that, but these go hand in hand. So maneuvering is the ability to perform a maneuver. Go figure, right? Makes sense. But you can also do planning, modeling. You can do calibration. I can reconstruct my maneuver based on components. I can then perform estimation on it as well. I can include that in some of the other capabilities we mentioned later, orbit termination and so forth. You can model pretty much any system you can imagine with any combination of tanks, thrusters, and valves. You can basically come up with any kind of chemical or electrical system you might have. Really useful. You have a lot of flexibility here. And even if maybe you're like, oh, my system is very unique, well, you probably have the coefficients and the components necessary in order to pull it together. And if you think you don't, ask us and we'll help you out. And then the most important thing here is you can simulate all different types of burns here, right? So you have the burns that last a specific amount of time. So, hey, I'm going to be executing a finite burn maneuver over this period of time, or I need to just treat an exact moment of burn, so I have some impulsive burn I'm modeling. Or maybe I have some kind of acceleration event happening. Frequently this is outgassing, right? You have some kind of like gas trapped in your system and it's just ejecting randomly or at some specific interval, and you want to perform analysis, see what that does to your orbit. You can do that as well. Now, maneuvering is obviously an important part of what comes next, targeting, because very regularly the targeting system is used to find maneuvers that make sense. The classic example of this being, gee, I have launched my satellite and I'm planning on getting it into GEO. How do I get it there? Well, you're not just going to magically appear in GEO. So in order to do this analysis, you have some kind of, low Earth orbit where you're in a parking orbit. You're going to have some kind of transfer orbit to get out to GEO, and then you're going to have some kind of final maneuver in order to actually stabilize you in the right orbit that matters. And obviously time and all sorts of factors play into this. How do we achieve that? And the answer is with the targeter. The targeter is very good for very simple systems. It will find a feasible solution to your problem. It will find something that works, which is good. The specific mechanics here, I mentioned a little bit about this. It's a 2-point boundary value problem that it's solving. There are seed values, so you can determine outputs. It compares those outputs to desired goals. Don't worry too much about the nitty-gritty of this. This is all documented as well. I mentioned this specifically because what comes next that we're going to be talking about is a more sophisticated version of this. And I need you to kind of understand, hey, this is basically how it works before you jump into this bigger thing. So before we move on to that bigger thing, though, I do want to call out that we have a presentation from Brian McCarthy later this week on Thursday at 2:30 p.m. Eastern. He'll be covering his 2-level targeter that he's developed with FreeFlyer. And this is a really exciting mission plan that's very sophisticated and is in use by NASA folks in order to solve challenging problems for upcoming mission design. So I won't steal any of it, thunder beyond that, but definitely tune in, it's really cool. Now let's jump into the more complex thing, optimization. So if you've been following the sales emails notifying you about new versions that come out, the savvy among you will realize that optimization is brand new to FreeFlyer as of the most recent release, FreeFlyer 7.6. So this multivariable generic optimization utility, it's for really complex and nuanced analyses. So say you have something that you want to get a real optimal solution for, and this happens all the time, right? So whereas the targeter will find a feasible solution, it'll find something that works, that solution might not be optimal, right? It might work, but it's not going to be the one that has the lowest fuel consumption, perhaps. It might, it's hard to know, but we need the optimizer to tell us if it actually is, or we need the optimizer to find the actual one if the targeter missed. A good example of this is actually in the image on this slide, right? So you can see kind of the troughs in this grid, and you can imagine that if you were the targeter and you were looking for any solution that's feasible, depending on where you started on this grid, you would land in what seems like a reasonable solution, and it would work. But it's not going to be the lowest point on that grid. And so you can actually see the optimizer's endpoints of its analyses kind of bouncing around until it settles on what is actually the minimum in this particular case. And you have some flexibility. You can, of course, tailor that and decide what makes sense for your system. There's a lot of documentation on it. A lot of this is going to be covered on Tuesday. There's just a whole bunch of presentations on it because it's brand new and it's really interesting to everyone. So please tune in for those starting at noon. It's going to go a long part of the day, and there's multiple presentations from multiple folks. Very cool stuff. I won't say too much more about it. The one thing I will call attention to is that 3 industry standard optimizers are supported here. You have NLOpt, you have IPOpt, and then you have SNOpt. In the case of SNOpt, since it is a purchased software, we do not provide it with FreeFlyer. If you want to use SNOpt, you acquire it on your own, and you can just drop the DLL that they give you into the appropriate folder, and FreeFlyer will talk to it. In the other 2 cases, because they are freely available, we integrate with them directly, so you have that option if you're just looking for optimization in FreeFlyer with no additional strings. So pretty cool stuff. Moving on from optimization, we're going to jump into orbit termination. There's a lot here. I'm not going to tell you too terribly much. I recommend asking questions if you have them, or looking at our documentation that I'll point out later. The most I want to say here is that roughly orbital termination, it's a weighted curve fit between the measurements and propagated state for a spacecraft. So you can see on this image, you have the truth state, you have your propagated state, you have your measurements, and you can see how the estimated state is basically following along with those measurements in order to give you a more realistic idea of where your spacecraft actually is based on where you think it is. And we offer a number of estimators in FreeFlyer for this. You have the Bashley squares, you have your common filter, both unscented and extended. With the unscented, you have the option of a smoother as well. And there is a square root information filter available for you to use. So essentially the rough idea here is finding out where your spacecraft actually is based on where you think it is. It's a good way of thinking about it. Jumping ahead, we have a lot on interplanetary analysis. Most of what we've talked about so far in FreeFlyer is typically used in an Earth-centered context. So I have, again, like a geo spacecraft, I'm interested in looking at Earth. Or I have some low Earth orbiters that are performing some analyses, maybe taking some image scans, all sorts of things. Commonly, these are around Earth. But FreeFlyer is very frequently used for interplanetary analyses as well. And you can set up analysis and force modeling for the spacecraft and ground stations around or on any central body you can imagine. And this can be ones that we provide default access to, so the planets, right, the moon, the obvious ones. Or maybe I'm interested in one of the Galilean satellites, and I can set that one up. You can set up IO or all sorts of things. And then you can perform analyses around that. You can set up their planetary constants so that they're actually correctly established in the orbit and setup. You can import a SPICE file so that you can actually get their orbital trajectories correct in the grand scheme of the solar system. You can configure your solar system and do all sorts of cool things as well. There's a whole solar system object for that. Gives you a lot of information on like nutation and precession motion and things like that. I could do any kind of gravity models as well. This is really useful if you have some kind of crazy system, like, wow, I've got an asteroid. Asteroids have these bizarre shapes. I need to set up some kind of gravity analysis for that. You can do that in FreeFlyer. And then lastly, an important part here is you can set up any custom vector or coordinate system that's useful for your system. So you have some, I don't know, moon-centered attitude reference frame or whatever you can imagine, and you want to use that, you can build that, you can use it. FreeFlyer lets you take care of that. Some common examples, I've mentioned all these already. You have your asteroids, your moons, your planets, so forth, also stars. And there's a cool picture here. You can actually see one of those Galilean satellites I was talking about. So we do have another presentation on this on Thursday at noon. Recommend tuning in if you're interested in kind of out of Earth contexts for FreeFlyer. Definitely check it out. Julie Peck will be going over that. Really exciting. All right, and then this came up a little bit before. I saw there were some questions in the previous presentation about terrain, so we'll briefly cover that here. FreeFlyer supports terrain modeling for visualization and line of sight analyses using pretty much any terrain file format standard that you see in the industry. Obviously, this is centered for the complete analysis. This is Earth terrain. Though you, like as Barton mentioned, you have options for visualization elsewhere as well, and the tech support team can help you set those up. Some typical user scenarios here. You have some GPS coverage analysis in a mountainous region. Maybe I have a vehicle going through a canyon. You can actually see that on the image here. I don't have the vehicle set up, but you can see a canyon that a vehicle might go through. And maybe I have a drone following that vehicle, and I want to make sure that the drone has line of sight, so we can check around that based on kind of the drone's movement patterns. Maybe I want to perform some kind of comprehensive view shed analysis representing the area that is visible from a specific location. This could also be maybe a visible area from like a drone that's moving around or a spacecraft or something. You can set up kind of some kind of communications link analyses here. This obviously plays very commonly with coverage and contact analysis. They work well together. Or I'm interested in LEO imaging is a good example of that. And here we have a topographical map built using point groups in FreeFlyer showing you terrain in FreeFlyer. Pretty cool stuff. I mentioned this briefly earlier. We have conjunction assessment and space situational awareness support in FreeFlyer. It's very commonly used. So this is the sophisticated version of where it came up before with the proximity zones, those ellipsoids. You can actually literally see them in the image here. That's what those ellipsoids look like. You can see how they bend based on a number of factors as you're propagating your spacecraft. And this is very commonly used for groups like all sorts of folks. If you have Space Force providing you with conjunction data messages, they might be using FreeFlyer to solve this problem. And you could be doing something like, I'm interested in my spacecraft versus one other spacecraft. Maybe I know a conjunction is coming up based on a CDM, and I want to now perform some analysis on that. Or maybe I want to do my spacecraft against a whole suite, like a whole constellation, for instance. Example being like Starlink. Or maybe I just want to run my spacecraft against the whole catalog, literally everything. Obviously, you can imagine that the scale here makes this pretty complicated. And so it's worth noting that FreeFlyer is perfectly scalable in these high-performance computing environments, where you maybe go all the way to the right and you say, let's look at literally every spacecraft and object against literally everything else and show me everything. It's going to run for a long time, and you want to be very optimal in your programming of this system, or it's going to bog down your system. So you want to kind of set it up for these conjunction screenings purposes. And there are all sorts of built-in methods in FreeFlyer to help you out with a number of this sort of thing. So obviously, TCA, time of closest approach, probability of collision, what's the actual number there? Very commonly used there. You want to have some kind of actual geometry analysis. So I want to, okay, let me see the orbits here. Maybe I want to perform some kind of maneuver to get out of the way. I want to see what that changed maneuver looks like, propagate it for a while. Does that introduce any further like potential conjunctions in the future, or are we good to go? Does that hurt science at all? I want to compare that to everything else I'm doing in my mission, right? I'm not trying to hurt whatever I'm trying to achieve. Some other examples, maybe you want to intentionally perform some kind of conjunction. In this case, we call it a rendezvous, right? It's a good thing. So this would be the example of I have something trying to dock with the space station. It's a very classic example of this. It's used on FreeFlyer right now. Some kind of proximity operations there. Other stuff, maybe I want to perform an analysis on the relative motion modeling between objects. A good example of this is, let's say you have a constellation of things in a tight formation, and you want to propagate these forward in time and see how they interact at different points in their orbit. Maybe they're in a very elliptical orbit, in which case you've got to be careful at periapsis that things don't get too close together, that it provokes a risk that you're not actually hitting any collisions. And so on the topic of relative motion modeling, we'll be learning a little bit more on Wednesday, so you'll be able to hear more about that then. So that covers essentially all of the important capabilities and features of FreeFlyer. We've hit on all the important stuff here. Let me briefly go over the learning resources available to you. I have some links here. You can Google anything that shows up here and get an answer. So the first thing is the FreeFlyer help file. It's available both online and in the installer. In the installer is important if you're working out of a classified environment, so you install it, you still have access to that help file, but you can also find it online. There's a link, you can Google FreeFlyer help file and find it. It's comprehensive, we write it regularly, it's great. I will also mention that the FreeFlyer technical support team can help with any questions you might have as you learn the tool. It's provided as part of our maintenance support policy to permanent users, and it's provided as well at a reduced level to university students. Obviously, we're not going to do your homework for you, but if you have a targeted question about something like, hey, can I achieve this? How do I do this? We'll point you to some pages and give you a little bit of a tip on how to work on that so you can figure things out. We also have YouTube channel on our AI Solutions channel. From there, you can get video training, complete training, as well as some one-off tutorials that are useful. You have access to the FreeFlyer blog as well, where we post nice little things that show you, hey, let's talk about this one topic in extreme detail. And it might be one of the capabilities we mentioned, right? Like interplanetary analysis or something like that, or constellation design, or you name it. And you can find that there. So there's a lot available to you. Obviously, please reach out to us if we can be of any help. I've provided a lot of contact information here. You can find me on LinkedIn as well. You know, look up my name. You'll find me matched with AI Solutions. Pretty straightforward. My contact information is here if you want to reach out to me for any reason. Obviously, tech support and sales are here as well if you want to reach out to kind of the distributions and hit on more folks. Feel free to reach out, and thank you so much for your time. I really appreciate it.
Thank you, Corey. It's quite a challenge to cover all of FreeFlyer's features and capabilities in just 45 minutes. I'm sure there's a lot of questions. We already have a few that will be coming in. We already have a few questions for you. So I'll go ahead and get started. Can you tell us about the difference between the FreeFlyer engineer and mission tiers? And are there other modules or tiers in FreeFlyer besides these two?
Absolutely, I can give you a little bit of insight there. So the engineer and mission tiers are essentially designed for different sorts of use cases, right? The mission tier has access to everything in FreeFlyer. So all of the capabilities we mentioned and all the features, everything comes with it. It's kind of a one size fits all. It's very commonly used for complete operations or complete ground system development. If you wanted to integrate FreeFlyer with another tool using that Runtime API, for instance, you'd really want the mission tier. The engineer tier, however, is more focused if I'm just doing analyses in FreeFlyer. If I'm just I just want to see how does this behave. I'm just interested in that one-off sort of thing. And you're not actually performing any hardcore like integration. That's a good example for engineer. And there is a pack available as well, specifically for our NASA customers, that has some very small tailored functionality specifically for them. It's called the NASA pack. Regularly, users don't need access to this. Very commonly, what will happen is that the feature overlaps something in the core of mission tier, so it's not a big deal unless you're a specific user at NASA and you're like, I really need this exact one model that only NASA uses. Then you might consider that.
Okay, thanks, Corey. So it's pretty much the engineer and the mission tiers, and thank you for highlighting the difference. I would like to remind everyone that we have approximately 15 minutes for Q&A now. We have some questions. We're going to go ahead and continue answering them, but please come with more questions, and we're going to be here for them. So Corey, was FreeFlyer used for gravity assist maneuvers? Can you speak about that for a little?
For aircraft assist maneuvers, is what you said?
Gravity assist maneuvers. Is that
yes.
FreeFlyer?
Yeah. Yes, absolutely. So FreeFlyer can't. So we'll kind of step back on this question first. FreeFlyer models the physics of astrodynamics correctly and fully. So if I have turned on the gravity model for a particular celestial object, let's say Mars or whatever, or the moon or whatever, when I perform a maneuver around one of these planets, you will correctly model the gravitational assist if that's what you're attempting to do. Now, obviously, there's extra steps there. You're not trying to get captured by the planet's orbit, for instance. You're not trying to get locked in there. You're using it to help you out, essentially stealing angular momentum from the planet. So the idea behind it is just the same as you would imagine. If you were going to program it in, you would have your maneuver that lets you kind of perform that action and gain that assist. And yes, it does model correctly in FreeFlyer.
Okay, thank you. So this one is too targeted. It's a great question, and it's about if FreeFlyer will be bringing more object-oriented abilities for custom objects. And the question comes with a scenario. So if I have a struct today that has a number of variables in it, and I have separate procedures to act on that struct. However, that's hard to keep up these things in sync and make sure they follow developers, and make sure developers follow with them and know which procedures are available for which structs. So given that scenario, for example, will FreeFlyer be bringing more object-oriented abilities for custom objects? What are your thoughts on that, and how can you approach that?
Sure, yeah. So obviously there's a lot to unpack there. The first thing I'll mention is that you can custom objects through the FreeFlyer extensions capability that I mentioned. So if you wanted to create something like that, that's encapsulated away, so that you basically just import that extension for everyone who's using it, and then that object is now available for them. That is an option. The structs were mentioned as well. If you're looking at data storage, like I'm trying to manage a lot of information at once, you could pass these around. You can use them as arguments inside of procedures that you maybe have as well. And you can kind of just make them all play nicely with one another. Obviously, as we move forward into the future, we're going to be looking to improve anything there. If there's a specific capability or kind of like IDE feature that maybe you're used to from Visual Studio or Sea Lion or whatever you're familiar with, let us know, right? In most cases, you're capable of doing that already in FreeFlyer, but there are going to be some exceptions, of course, right? We haven't done literally everything that every IDE can do. So let us know if there's something that's specifically of interest to you. We'll prioritize that based on that interest. So again, the more people that ask for something, the more likely it's going to happen soon. Hopefully that answers your question. If there's some specific targeted example you'd like me to walk through, go ahead and ask it in chat and I'll follow up with that.
That's clear, Cody, and we're going to get into this more, the requested features that are being mentioned, and we're going to be communicating directly with stakeholders who are talking about this. So this will definitely be, as you mentioned, followed up with. We have more questions for targeter and maneuvers. So can a targeter solve a trajectory for landing on a celestial body?
Sure. So you can perform analyses within atmospheres of FreeFlyer, but it's worth noting that, as has been mentioned before, FreeFlyer is primarily a space-based application. And this means that all of the forces that are on by default are going to be space-based forces, right? So your gravities, your drag is important and an important part of it, but there are also a lot of nuanced sort of behaviors when you get close to a planet, especially if you're thinking about landing on Earth, for instance. There's a lot going on there. So the tentative answer is yes, but you're probably going to have to build out some custom forces for whatever you're particularly relevant looking to analyze there as extensions, import them in and analyze those forces. And then once you've done that, then yes, FreeFlyer's targeter and optimization systems can integrate with these extension forces that you've built in. It just has that extra step of actually telling FreeFlyer what forces you need to work with.
Yeah, that makes sense. It's a big problem, as you mentioned. There's a lot of layers that goes into it, and I think you summarized how to approach it from high level very well. So you talked a lot about FreeFlyer scripting at some point. Now, there's a question on how is the FreeFlyer scripting different or unique, and what are the limitations to the scripting capability of FreeFlyer, the scripting feature, excuse me, of FreeFlyer?
Sure, yeah. So what are the limitations? Well, the way I would pose this is that the sky is pretty much the limit when you have a fully open-ended scripting language like this. If I really want to achieve something, I can do it. Now, you have interfaces in virtually anything into FreeFlyer. I can make a custom force, for instance. I can create an algorithm that does virtually whatever I'm looking for. There are, of course, some limitations in, like, I wanted to build my own integrator, for instance. Okay, that's going to be pretty difficult. What's more likely going to be realistic is you ask us for an integrator and we implement it. So if there's like a specific feature that's missing, sure, that's a fair point. What makes it unique, though, is that FreeFlyer is built scripting language first, is the way I like to think of it. We're building it with the scripting language in mind. We're making sure all new features that get introduced are well integrated into our current existing IDE. So this could be working with commands if reasonable. A command being like my while, doing something, do this loop more or less. Or it could be something more object-oriented that's very focused on the object itself. Like for instance, the optimization feature that we just released. You'll see that that's very object-oriented. It's all focused on the object. And there are a dozen different approaches we could take there, right? But that was the one that made the most sense when we were testing with our users. We're obviously interested in your feedback on these topics. So if anything comes up, again, if you think that, man, there's some IDE capability that's in these other tools that I'm just not seeing, let us know. And we'll make sure to get it in, because trust you and us. You know, we're using this tool too. I mentioned that AI Solutions is a software and services company. And so anything that you come up with, man, we're feeling it as well. So
I think you summarized it very well, Corey, when you mentioned the sky's the limit. You got me there. But thank you for that elaborate answer. So this question is about learning how to use FreeFlyer. We have some people who perhaps will, they're asking on how can you, if you have some background in Astrodynamics, if you're familiar with other tools, and if you know how to script, then what would be the best way to go ahead and start using FreeFlyer? How can you learn, that learning curve? How hard is it? And what would you recommend?
Absolutely. Yeah, I love this question because I love answering it. So it depends a lot on where you're approaching this from, right? So if you're coming at this from, I need to learn how to do Astrodynamics better, and I want to use FreeFlyer to do that, we have something that is specifically tailored for university students, but is widely applicable beyond that as well, called the University Guide. And this University Guide essentially teaches Astrodynamics using FreeFlyer as a base. Now, that's a super effective way of approaching this, and it's using a lot of the problems that come right out of the schools these days, colleges these days. Our interns work on these problems, build them in, so we're making sure the language is right and everything. So that's great if you're trying to learn Astrodynamics a little more. The inverse is true as well, right? So let's say I know Astrodynamics pretty well and I want to learn how to use FreeFlyer. In that case, there's a whole suite of things available to you that come with FreeFlyer. You have the YouTube tutorials that I mentioned, the full training modules that are up. You can just go and watch them and participate in them. There's the certification program that'll give you some things to work through, a good way to learn if you've actually reached a point where you're functional with it. You have the help file that's available online and with the installation. You have sample mission plans provided with FreeFlyer itself. These are going to be things that actually show you, and they're designed to be instructional. How do I achieve this? Some of them, the ones that you see on the front screen when you open up FreeFlyer, are going to be showcasing capabilities and features and things. Some of them are going to be showing you how to achieve some task. And those are going to be really helpful for learning, connecting the dots between this is some Astrodynamics capability and thing I need to do. How do I make FreeFlyer do it? That's the best way of connecting those dots. So hopefully that answers the question from all angles.
I think that addresses it very well. Thank you, Cody. So we have 3 more questions for you. One of them is, can users define propulsion types? For example, let's say a futuristic topic or something being under development right now, like nuclear propulsion of a spacecraft while doing maneuvering in stellar medium. I'm not quite sure what stellar refers to, but I think you got
Sure.
that.
No, I follow the question. So the idea being, if you're looking at a specific type of propulsion that maybe is not native to FreeFlyer right now. So the example being nuclear. Now, in this case, you can set up you have a lot of constants available to you when doing kind of your thrusting capability in FreeFlyer, and you can set up a lot of features there. So you can pretty much put together what you're looking for. Now, if you're looking for something that's like low thrust, I will hopefully not spoiler too much from upcoming presentations, but we will be working towards implementing, additional native low thrust capabilities into FreeFlyer 7.7, the upcoming release sometime next year. And based on that, stay tuned. If you're interested in that and specifically you want to provide some more insight, Sarah Fields will be giving a presentation right after this. And she's our product manager. She does a lot of that strategy and design and development there. Ask her questions about it. Make sure she hears that you're interested in it. And if there's something specific beyond that, of course, let us know and we'll make sure to bake that in as well.
Yeah, thanks for that, Corey. So these 2 questions are actually more related to the upcoming session, but I will say them now and feel free to contribute their answer, but I believe they'll also be addressed later. One of them is macros have been around in FreeFlyer. However, you cannot debug into them yet. Will that be coming in the software? And I believe we're working on that, right?
Yeah, that is. So I understand the issue there. Yeah, absolutely. So there is a potential significant amount of work being done on a lot of different scripting capabilities in the future. It's hard to give a specific timeline for this because we're kind of looking at the whole FreeFlyer experience holistically. But yes, I will say at a minimum that is something we're tracking. If there's like we can definitely make sure that's tracked specifically if that's something we could address sooner maybe, but as opposed to waiting for the holistic kind of consideration. But yeah, hopefully that answers the question at least.
Yeah, it does. And the last point here is, will unit testing or a testing framework be coming into FreeFlyer? And I believe it has a similar answer to the one that you just mentioned, right?
Yeah, so actually unit testing is something that we've gotten requests for in the past. We're definitely tracking it. You have the ability to kind of do something similar to unit testing right now. We have some groups in flight dynamic systems right now that are setting things up and making it kind of work out. But whoever asked that question, please reach out to us, because we're very interested in specifically your use case for unit testing, what you would expect out of that, because that has come up before and we're looking for feedback on that. We would love to interact with you on that and kind of go back and forth and see what makes sense for your use case.